Let's take an example of a C-chart and a U-chart situation where we have some defect data we want to plot in terms of control for our overall process. So my presentation here is simply going to show you an example. I'm assuming you've got the equations and the process for building the chart out of your text readings. So I'm just going to take you through the example. Here's an example where we've got a bunch of defect data. We've drawn 30 samples of 50 products out of our production process. What they are doesn't really matter for the sake of this exercise. With a sample of 50 taken from each run of 30 runs, we've recorded the number of defects here in row 7 of our spreadsheet. So that's our defect count. So we have a certain number of defects per selected sample. What we want to know is the process producing these defects under reasonable control. So presumably the defective counts and the X bar charts for this process are in control, or we wouldn't be having this discussion as we go through. So let's see what we do to actually build on this process as we go. First, we want to know what our C bar is. What's our average defect rate? That's simply the average of the 30 defect counts coming through as we go through. So that one's pretty easy. And then we can calculate our control limits using the formulas that take the average plus or minus 3 times the square root of that average. So we can calculate our control limits and then carry that data across, because I'm going to graph it in Excel, so I need my data to be propagated so I can do my line charts. If you're going to graph this by hand or you're not using Excel, you wouldn't need to do that step in order to create your chart. But then from that I can create my chart. Here's my C chart of my data. I can see that the process's production of defects, the defect density of my defectives, is not in control. I can see outliers in this process as I go through. Now I created a C chart because my sample size was a constant. I had 50 samples in each observation that I took. What if it had been different? What if my numbers had been different? So this is a C chart because my sample size was constant. I could have drawn a U chart. Now I have to draw a U chart if my sample size isn't equal, but there's nothing to stop me from drawing a U chart when it is. The difference is that on the U chart, I'm going to use the individual sample size in the calculation to calculate the ratios. On the C chart, I didn't have to because it was a constant. But if I draw a U chart with C chart data, I get the same results. The scale tends to be very different because now I'm looking at the proportion that are off. Like I said, back here on the C chart, it was the number of defectives I had here on the side. On the U chart, I can't plot numbers because that's not relevant anymore. I can't harmonize to that. So I've switched instead to a ratio as I go through. So whether you're doing a C chart or a U chart, the U chart is kind of universal. You can always do that. It just depends on whether you want to talk about the proportions in terms of percentages or the actual numbers. But you can only talk actual numbers if your sample sizes are actually the same as you go through. So let's imagine a scenario where they're not. So here's the same basic setup, only this time the sample size is different each time. It's a variable number, generally around the 50 that I was after, but sometimes I get a little more, sometimes I get a little less. So what happens if my sample size is actually different? Well, I can calculate my average overall will differ. The number is slightly different than it was for the C chart because the weighting of these defects is different based on the sample size, but it will usually be reasonably close as I go through. So I can then calculate my U value. My proportion in each sample is done by simply the defects divided by the sample size. So I get a proportion for each sample as I go through, and I'll have my center line sample associated with that. So I can now start to take my U bar, which is at 0.24. I'm going to treat that as a straight line. I can calculate my limits using the formulas for the limits of a U chart, and notice it's taking the sample size directly from this observation, and it will each time, which is why the control limits can vary slightly looking across the chart because I'm dealing with different sample sizes. When I chart my values, I get pretty much the same blue line almost that I had before, my center line, my blue line of the data, and now notice a slight variation in the control limits on the high side and the low side as I see my way through. That's because of the sample size. The larger the sample size, the tighter my limits can be coming through. The smaller the sample size, the larger the limits I have to have. So it's the variability of the samples of the limits is simply a measure of the inherent variability of my data as my sample size changes. So when I've got my largest sample sizes at 60, I'm going to have my smallest limits. Now in this particular case, this is almost effectively a straight line. but they're only off by slightly. So my sample sizes were reasonably similar going through. That sometimes you'll even do a chart where you just take the average sample size going through and make that work for you as you go through, or just replot at 50. But we do have some outliers going on in this data, so we might want to analyze the data at this point and say we have 3 outliers that cause us to declare this process out of control. So what do I want to do about that? I would investigate my 3 outliers. I'd go look at case 4, 9, and 27 and say, can I identify the special cause that resulted in these particularly high defect rates in those samples? Maybe I can, maybe I can't. But let's suppose that I go out and do the research and I can identify the cause of the defects in the 4th case and the 9th case, but not the 27th. And I know I've gone out and I can correct the cause in 4 and 9. So I am correcting the process for whatever caused the data to go askew in samples 4 and 9. If that's the case, I'm allowed to remove this data from the data set and recalculate the limits accordingly to see what's left in terms of special causes. Since I don't know what caused number 27, I can't remove that data point. It's not arbitrary. You have to know, you understand the cause, and you in fact have eliminated it from your data. But be careful, based on how you build the spreadsheet. Here's a case where I simply blank out the data or delete the data associated with the 2 cases I'm allowed to delete, and look what happened to the chart. It goes all over the place. This is a function of Excel. How do you propagate the values across? And since these values for the U-bar I built to look at the value to the left, I actually lose data values when I delete values. So be careful doing this, and don't just hide the columns either, because hiding the columns makes your display look like it's the right size, but it doesn't actually eliminate the data from the chart. You have to go through and actually take the data out and correct for those data anomalies as they go through. Here's the adjusted data. Notice I didn't let the sample sizes propagate. It is 4 that's gone between 3 and 5, and it's 9 that's gone between 8 and 10. So I don't change these sample identifiers as I go through this process. But here's the process with slightly different control limits. My 27 outlier is still there. Note that because the control limits were recalculated, it was likely or at least possible that new outliers were going to show up when I did this. In this particular case, I didn't. But if the limits had tightened up a lot as a result of removing those data points, it's possible that this point here might have become an outlier. So pay attention to that as you go through. Eliminating special causes that are driving you out of control does not necessarily mean that the control chart will fall into control. You could have an iteration you have to go through to identify and remove special causes before you find your data completely associated with that. So as I go through, so looking at the data, I ended up with some negative points here on the data. Since I know that this is a defect count, I can't have a negative number of defect counts. So I typically will at the last minute adjust the data to eliminate that. And the way I do that is for all the cells on the lower control limit, I simply give it an Excel max function. Give me the maximum of 0 or the calculated value, which will return 0 if it is negative and has no impact otherwise. If you find yourself in a situation where you're reluctant to set this to 0 when it's negative, ask yourself why, because even if you're not talking about defects, if you think you're talking about something else where maybe the value could be negative, that means you're not following the purpose of the C and the U chart. The C and the U chart are based on a Poisson distribution. A Poisson distribution is a discrete distribution with only values that aren't negative, 0 and above. So if you find yourself thinking you need a negative value on the control limit, go back and double check the kind of data that you have. If you think you have negative data that could be valid in your situation, go back and revisit the X bar R and the X bar S charts, because they're the only ones that will have negative control limits. A Poisson constitution cannot have a negative value. So setting that 0 value for the negatives is a good idea. A lot of people on defect charts don't even set a control limit on the low side because you want to have as few defects as possible. But the fact that sometimes the value rises above 0 is an important sign. If a data point comes very low, it might be a good thing for your process, but it still would be an indication that your data was out of control. You'd want to investigate and ask, why did we have so few defects in that particular case? So don't just arbitrarily not plot the lower control limit because you think a low value is good. Even a good value when it's an outlier taking you out of control is something you can learn from as you go through. So that's the basic logic of the C and the U chart. They're all basically the same. If you know Excel, you can build one of these spreadsheets in a few minutes, and I encourage you to do it in Excel on a regular basis. But be careful how you delete those extra columns as you go through. You don't want to lose data values and misbuild your chart because of the way you're doing it. That's purely a function of knowing Excel, and be careful about how you've propagated the data across the page.